Thank you, Stefan. Yeah, it is actually the world's largest information store of information models, of digital twins, whatever you want to call them. So let's talk about the Cloud Library, where it came from, why we need it, and its adoption today. So the basics, it's a cloud-based library. It's very scalable. It runs on any cloud. It's cloud independent. In the working group, we had representatives from Google, Amazon, Microsoft, or we still do. I mean, we're still improving the cloud library on a continuous basis. But really, it was important to really get all the major cloud vendors together and come up with a good architecture. So again, it's using OPC-UA. Obviously, it's this online store of OPC-UA information models. You can upload those information models in Node-Z2 file format. It has a REST interface. It has a GraphQL interface with a spelling mistake. And it has been a joint working group defining Cloud Library together with our partner, the Clean Energy Smart Manufacturing Innovation Institute in the US, SASME for short. Part 1 of the spec has been published last year. It's covering the architecture and use cases. Part 2 of the spec is in final review. So the review round within the OPC Foundation's Technical Advisory Council has completed. It covers the API definition, and we're nearing completion and releasing that as well. There's an open source reference implementation on the OPC Foundation GitHub, but you don't need that reference implementation if you just want to use it, because the OPC Foundation actually agreed to host an instance of it on their dime, which is great. So just go to uacloudlibrary.opcfoundation.org. You can access it today. Some of the benefits, and I talked about these before, so very briefly, obviously, in the past, when you're doing an industrial IT project, the first step was always to connect your assets, figure out the OPC-UA information models from those assets, or convert to an OPC-UA information model if the asset doesn't support OPC-UA natively, using some of the well-known industrial connectivity software solutions out there. And then, you're basically building your analytics pipeline in the cloud as a next step. Wouldn't it be great if you could do that before connecting the assets, or even in parallel would also be a big improvement? Because usually, the connectivity piece is done by the OT folks anyway, and the cloud analytics piece is done by the IT folks, so they're waiting on each other, right? So now you can upload the OPC-UA information model to the cloud library up front. The IT folks can build their analytics pipeline up front, and all you have to do is do the connectivity piece when you get around to it, right? So obviously, another big benefit of the cloud library is to see what's already out there, so you don't have to start from scratch every time you're building a new OPC-UA information model. And most of the information models in the cloud library are actually VDMA companion specifications that have been defined by the experts and should be considered best practice, right? You can also use it for simulation, of course. So if you're building a new production line, you want to simulate it before you actually build it, you can download all the information models for the assets that you want to purchase, should they be available. So obviously, if they're not, then you should talk to your machine builder to put them up there. And the cloud library actually verifies the information model as well during upload, so you can use it as a verification step. So what does it actually look like from an architecture point of view? So it's quite simple, actually. It wasn't that hard to make it cloud agnostic. So really, there's 2 different interfaces that the cloud library uses. There's a storage interface and a PostgreSQL interface, or database interface. And the default implementation of the cloud library, the way that is in the OPC Foundation GitHub repo is for storage. We support the Azure Cloud, the AWS Cloud, and the Google Cloud. And for the iDatabase interface, we currently only have a PostgreSQL implementation, but it is not hard to add different databases. Already mentioned, there's a REST interface. Right now, it's OpenAPI compatible. There's a Swagger UI that you can call as well to try it out. And then there's a GraphQL REST interface. And again, there's two different UIs for GraphQL built into the reference implementation, the GraphQL Playground, which everybody uses, and then another one which I forgot what it's called, but it's in there, trust me. So in figures, we have currently 251 active users, which is quite significant for something so specific. We have 67 information models available, and all the VDMA companion specs that have been released are in there. So really, it's a great starting point for your next industrial IT project. In the reference architecture that I always show everyone, you can see it here. So it is used to look up metadata for time series data, which is one of the key use cases. But there's others. There are other use cases as well, and some of the adoption I'll talk about now. So first of all, obviously, Sesame, our development partner, is using it significantly in their smart manufacturing platform. They're using it as their marketplace, what they call smart manufacturing profiles, which happen to be OPC-UA information models. And they're also actually building, or they are building right now, a tool that they call, sorry, one more slide on the innovation platform. So you can import the OPC-UA information model directly into the platform, as you can see here in the screenshot. And the tool that they're working on is what they call the Profile Designer. So it's an OPC-UA information model designer between you and I. And this Profile Designer also has the capability to load profiles or OPC-UA information models directly from the CloudLibrary. I already mentioned in the previous talk that we built a carbon reporting demonstrator, also leveraging the UA CloudLibrary. So this is quite important because it's a great way to look up additional data from the assets manufacturing a product where you need to calculate your carbon footprint from. So most of the time it's energy data that you want. Sometimes an asset also has other emissions, which you can probably calculate if you had access to the OPC-UA information model and a real-time telemetry stream of data as it's producing things. So obviously you need the cycle time to calculate the carbon footprint of each part that it produces. So you can say, okay, the part that it produced was in the machine for this amount of time, and that means during that time, any emissions produced, including the energy consumption and the emissions produced producing the energy it uses, need to be part of the carbon footprint of that produced asset, of course. So already mentioned in the previous talk, here's the link again. An asset admin shell server can obviously query the CloudLibrary. So you don't need to put the whole OPC-UA information model directly in the asset admin shell, but you can just add a reference to it and then download it when you're viewing and reading and parsing the asset admin shell. Another tool that integrates with the UA CloudLibrary is the UA Notepad web viewer. I built it myself. I contributed to the Digital Twin Consortium. You can see it there on their website. It's quite popular. There's over 1 million downloads already. And it integrates with the CloudLibrary. You can load OPC-UA information models directly from the CloudLibrary. And you can also upload OPC-UA information models to the CloudLibrary from the tool. So that's quite useful. And then, as I mentioned, there's also integration with Microsoft products. For example, our time series database called Azure Data Explorer, and it can read OPC-UA information models directly from the cloud library. As Azure Data Explorer uses Custo, which is a query language. It's open source. It's on GitHub. You can see it there, and it's similar to SQL. So you get this particular query here to access the cloud library, authenticate with it, download a particular notepad file. In this case, it's the Festo machine information model that we use in the carbon reporting demonstrator. And then you can import the information model directly into a table, which is displayed here. As you know, then look at and then use it as a lookup for OPC-UA information as your telemetry stream and OPC-UA pops up format comes into that time series database. Okay, that is all I have. Jonathan, would you like to take over?
Okay, great. So firstly, a quick introduction about myself. I'm Jonathan Malessa. I'm the team lead and product owner of OPC Router, which in turn is a product of the INRAE Industry Software GmbH. We as INRAE have been developing industrial software for over 25 years, and we've focused on Industry 4.0, IIoT, connectivity, and MES for all this time. We've been a long-standing OPC Foundation member and active contributors to different working groups, like, for example, the UA Cloud Library. Quick introduction to OPC Router. It's a software router with many different plugins, enabling you to communicate with a bunch of external systems and transfer data between those systems, which usually cannot communicate directly with each other. If you would like to use OPC Router, how can you deploy it? It's not only deployable to Windows systems or virtual machines, but you can also deploy it as a simple Docker container. So you're enabled to use it in Linux environments, on Kubernetes clusters, or even deploy it to edge computers fairly close to producing machinery. OPC Router, as the name implies, is a capable OPC UA tool. And let's take a quick look at all the OPC capabilities OPC Router offers. Firstly, the UA client, of course, offers data access capabilities, including subscriptions wherever it's fitting. You can interact by reading and writing complex data types. You're enabled to call methods, consume events, and handle alarms. And all of the aforementioned capabilities are implemented in a manner that you can browse whatever you need. So there's no requirement to know any node IDs, any browse paths. You can just use a graphical browser to select whatever you need. The entire connectivity is implemented in a secure manner, of course, and it even implements some logic level handshaking to ensure data that should be transferred has been transferred and reached the target system. The OPC UA server paints a fairly similar picture, as it also enables you to offer data access, data points, which support subscriptions, complex data types, or offering methods. You can, of course, browse all those things as you know it. The connectivity is as secure as with the UA client. It implements the very same logic level handshaking. Additionally, there's the address space designer and, of course, UA Cloud Library integration. The youngest but not less mature OPC UA capabilities are PubSub. We've implemented the data reader and data writer, of course, with browsing capabilities and secure connectivity, as previously mentioned. Let's today take a look at how easily you can adopt companion specifications as a UA server. So let's imagine there's some machinery and this machinery provides data in the form of an XML document, which is hosted on an SMB file share, and we are required to provide this data as an OPC UA server, which is compliant to the machine tool companion specification. The tool of choice, of course, is the OPC router. Let's take a quick look at how the user interface looks. On the far left column, you can see all the available plugins. So it's quite a lot and probably pretty small. But in the center, you can see a bunch of resources linked. So you have the quick start guide, knowledge base integrations, and even references to the international distributors if you require support in different time zones or languages. Let's create our UA server instance. So we are greeted with this setup screen for our instance, where we, on the right side, enter the name, the port that will be available on, sample rate, configure some security settings, and in the bottom, even user management. But let's switch to the node sets. And over here, we can import from the UA Cloud Library. And after entering the credentials from the UA Cloud Library, we can browse by default the OPC Foundation hosted instance. But you can, of course, add additional instances if for some reason or another you have to access a private instance which isn't publicly available. Built into the UA Cloud Library and, of course, this client implementation are powerful search tools and filtering. So you can't just search using the search bar, but you can also filter using the column headers. And once you've found what you need, you simply select that and confirm it with hitting OK. The client implementation of or the UA Cloud Library client implemented in the UA Server plugin doesn't just pull the node set selected, but also all of the dependencies which are required to make use of the selected node set. So switching back to the address space, not only a couple of nodes have been created, but also a directory, because all of those are marked as mandatory in the node sets selected. Let's create our first machine. Let's name it machine 1 and change its type. So we can just start typing and let's search for GMS. And once we've found what we are looking for, we just select the GMS type in this case. And all the mandatory nodes for the GMS type, the entire hierarchy is created automatically. So no need to configure all of these all of these things manually. You may or may not add optional nodes as you require it for your setup, but it's perfectly usable just as it is right now. Let's take a look at the data transfer. On the left side, we have the SMB trigger, which starts a data transfer, followed by the XML so-called transfer object. And let's take a look at the configuration of the XML transfer object fairly quickly. In the center, we have the XML document, which will be parsed later on. This is just a template, and this has the contents of one exemplary XML file. I've just picked and copy pasted the contents, as this assists me in setting up the extraction XPath expressions. So as you can see, the first row, the product instance URI is highlighted in the expressions table, and as is the XML node in the XML document in the center. So you can easily cross-reference those. But now let's add our OPC data access element and configure it. And to configure it, as mentioned earlier, we can use a tag browser, which offers visual assistance by just being able to click through the previously created address space. Within the machines directory, the machine 1, we have the identification directory, which was automatically created. And there, let's select all the nodes we would like to write to. And after all the nodes have been selected, we just confirm those and confirm the entire configuration. Now, it's simply a matter of drawing arrows from the XML element to the OPC data access element. I guess a slide got lost there. So please imagine a couple of arrows, just like from the file content of the network file access trigger to the XML document, from the individual data fields in the XML element to the OPC data access data points. And with that, the entire data transfer has been configured. So it's very easy to set up, very easy to consume knowledge which is stored in the CloudLibrary. And by this, the network file access trigger monitors the SMB file share for any changes. Once some changes are detected, new data transfer is initiated, the XML document is read and parsed, and all the contents are written to the OPC UA server and made available compliant to the machine tool companion specification as selected earlier. So the goal was to make the data available that the machine currently provides as an XML document in a compliant manner to the companion specification. And this was done through OPC router. But of course, this is not the only thing you can source the data from, as you can cross-reference any of those and even more systems to gather data, to combine data, merge data together, to provide them as you require some additional data points for OPC UA servers, which may or may not be provided by the machine itself. So you could aggregate data from different systems together and combine those to a single OPC UA server address space. And let's take a look at the output of the joint working groups, which through the UA CloudLibrary is made available to a bunch of consumers. So all of the great joint working groups where industry experts are designing specifications and using their expertise to define node sets, to define relations between those data points, and to define standards or standardized node sets, standardized information models. They can use tools like the UA Node Set Web Viewer, the Unified Automation Model Export plugin, or the Sesame Profile Designer to publish the defined standardized node set informations to the UA CloudLibrary, which in turn can be used by, for example, the Azure Data Explorer, the Asset Admin Shell, the OPC router, the Sesame Profile Designer, once again, maybe you in the future, or even OPC UA PubSub, as it's currently being extended, as Erich already mentioned in the previous talk, regarding linking directly to UA CloudLibrary contents. That was the quick overview over how you can very easily adopt companion specifications using contents of the UA CloudLibrary to empower your UA server to be companion specification compliant very easily. Thank you for your time.